So now that we're looking at something called z-scores, we can actually relate these back to the normal distribution quite easily. So we have Alexis in her school jazz band. Band members practice an average of 16.5 hours per week, so that would go right in the middle of the normal distribution. And Alexis practices, standard deviation of 4.2 hours, with Alexis practicing 22 hours. So from that 4.2 hours, we can come up with the rest of the spots on our normal distribution. So we'd have 20.7, we'd have 24.9, and 29.1 going to the right. We would have 12.3, 8.1, and 3.9. The issue here is that Alexis practices 22 hours per week, which would be somewhere in this neighborhood. Her practicing level doesn't actually fall on a line where we could actually go and use our percents. 34, 13.5, etc. We would have to divide this 13.5% into some part and some other part. Well, the issue is we don't know exactly how much is to the left of Alexis and how much is to the right. So that actually allows us to use something called a z-score, which a z-score basically tells us how many standard deviations away from the mean an object is. Now, somebody with a z-score of, let's say, 24.9, they would have a z-score of 2 because they're 2 standard deviations above the mean. Somebody with a z-score of 12.3 would have a z-score of -1, 1 standard deviation below the mean. So how do we calculate that? And this formula is going to be really important for a few different things. Z equals x minus mu over sigma. X is the item that we're looking at. So that would be Alexis's 22 hours. Mu is the mean of the population. In this case, it would be 16.5 hours. Sigma, standard deviation. So if we go to calculate Alexis's z-score, it would be 22 minus 16.5 over 4.2. What a lot of you may try to do is you may try to calculate this all in one step. If you do that, some calculators may be okay and be able to handle that. Some calculators may not. So to be safe, always do this in 2 steps. Do the top first. That would be 5.5. Then divide it out. With z-scores, it's always customary to go with 2 decimal places. Even if it's an exact value of 2, you'd always go 2.00. So you do that, you'd get a z-score of 1.31, meaning that Alexis is 1.31 standard deviations above the mean.